How to guarantee idempotency in distributed systems. Hello, everyone. Today, I'd like to walk through idempotency in distributed systems. In distributed systems, failures are unavoidable. Requests time out, messages get duplicated, consumers restart. So the real question is, what happens when the same request is executed multiple times? If we don't handle this properly, we can easily end up with double charges, duplicated orders, or inconsistent state. When thinking about idempotency, I usually break it down into 4 approaches. First, idempotency keys for API requests. Second, database constraints for write safety. Third, event deduplication in streaming systems. And fourth, designing naturally idempotent operations. Let's go through them one by one. Idempotency keys. Let's start with idempotency keys. This is the most common approach for client-driven APIs. For example, in a payment API, the client sends an idempotency key with the request. On the server, we check if the key exists. If not, we process the request and store the result. If it exists, we return the previous result. This ensures safe retries and no duplicate execution, but it requires storage, expiration strategy, and careful key design. So the key idea is idempotency keys turn retries into safe operations. Database constraints. Another approach is database-level idempotency. For example, using a unique constraint like user ID and request ID. Even if the request runs twice, only one insert succeeds. This gives a strong guarantee and simple implementation, but it mainly works for create operations and simple cases. So the key idea is databases can enforce idempotency at the storage layer. Event deduplication. In event-driven systems, duplicate events are common due to redelivery or consumer restarts. The solution is to store processed event IDs. If the event already exists, we skip it. Otherwise, we process it. This ensures correctness under at least once delivery and prevents double counting. So the key idea is event systems must explicitly handle duplication. Idempotent operations. Now let's look at a deeper approach. Instead of preventing duplicates, we design operations to be naturally idempotent. Instead of decrementing a balance, we set the final value directly or use version-based updates. This removes the need for deduplication logic, but it is harder to design and not always possible. So the key idea is the best idempotency is built into the operation itself. Real-world composition. In real systems, we combine multiple approaches. At the API layer, we use idempotency keys. At the database layer, we use unique constraints. At the event layer, we track processed events. And in business logic, we design idempotent operations. So the key idea is idempotency is enforced at multiple layers. Summary to summarize. Idempotency keys protect APIs. Database constraints protect writes. Event deduplication protects streaming systems. Idempotent design protects business logic. Closing insight to conclude. Idempotency is not just a retry safety feature, it is a core correctness guarantee in distributed systems. Because retries are inevitable, but incorrect results are not. That is what we must prevent. Thank you.